Hello and welcome back to Data Analysis and Visualization. I'm Javita Christie, and in this video, I'm going to continue with my introduction to statistics as I did in the previous video. So in this, we are going to study about exploratory data analysis, how you can summarize data, analyze data. So that's what we are going to see, and let's begin. First of all, we are going to answer the question, what is data? Data is nothing but pieces of information about individuals organized into variables. And there are two things here that you need to know. The first is, what are individuals? Or who are individuals? Now, an individual can be a person, but it can also be an object. Just like we saw earlier in the previous video, that population could be population of human beings, it could be population of mice, which are not human beings. It could be a population of houses, which are not even animate objects. So an individual here also can be a person, or it can be an object. A variable, which is the second part of the definition, which is pieces of information about individuals organized into variables. So variable is a particular characteristic of the individual. So variable is a characteristic or property of that individual. If I were describing a house as an individual, then what are the characteristics of the house? The location, the number of rooms, the area. So all these things are characteristics of or properties of houses, and those will be our variables. Now, let's see what a data set is. This is very important in this entire subject of data analysis and visualization, because we'll be working with a lot of data sets. So let's try to understand what exactly a data set is. So a data set is a set of data identified with particular circumstances. And those circumstances could be anything. For example, finding the opinion of people on the death penalty, finding how mice react to a particular chemical, and what are the prices of houses in a certain area. And that is what a data set is. They are typically displayed in the form of a table, and so tables contain rows and columns. The rows represent the individuals, and the columns represent the variables or the properties of those individuals. So dataset is very simple. It's just a table, and you could either create a database out of this, or you could just keep it in an Excel file, or you could keep it in a CSV file, and that's it. That is your dataset. Now we are going to see what a dataset looks like. So a very simple example of a data set. Now this is the data set that I have here, and you can download this for yourself too. I have linked this down below, so you can click on the link and take a look at it, and you'll understand what it is. So it's just an Excel file for now. We are of course going to learn how to analyze these types of files in this subject. But for now, you just need to understand what exactly a data set is. So this is the data set. And you can see there are several columns in that. And each column depicts an individual. Each row depicts an individual. And the columns, they show the properties of these individuals, as I had explained before. So the first column we have is hospital. And there are numbers given, 1, 2, 3, 4, and so on. So this shows which hospital it is. So 1 means the person went to hospital 1. And then we have the treatment. Now what this data set is, it shows individuals being treated for depression. And so there are several drugs mentioned here, several medicines mentioned here, and their effect on the person. So the treatment for that the several medicines which were used in those hospitals is given, and the outcome is given. Outcome which shows occurrence or no occurrence. Outcome which shows recurrence and no recurrence. So the recurrence means even after taking this treatment from this hospital, the individual was still facing the same problems, issues related to depression. So those were recurring symptoms. But in some hospitals, for some treatments, there is no recurrence, and so that is what is given an outcome. And then the time is given for how long they suffered from this type of a problem and how acute the problem was. It is also given what was the age of the person who took that medicine, and then the gender is given. So in case of gender, we've only given you 1 and 2. It's, however, very much it's necessary that you replace those 1 and 2 with male and female, because that's what we understand better. So labeling the data in a way that we understand always makes us understand the data set better. So you could use the find and replace option in Excel and label the data, and that is data analysis right there. A very simple step, but that is a step in data analysis. So this is the data set, and I hope you've also taken a look at it by downloading the file that I've linked down below. Now we are going to see a random sample of 1,200 US college students, because this is another type of data set that we are going to see right now, where there was a random sample of 1,200 US college students was asked, and they were asked the question, which is, what is your perception of your own body? Do you feel that you are overweight, underweight, or about right? This is a very simple question, and this was the question asked to about 1,200 college students. And as a result of their answers, this is the sample data collected. So this is the sample data collected as a result of their answers. And this is not the entire data, but it's just a part of that data. And so it starts from student 25, saying that the body image they have is overweight, and then 26 is about right, so and so on. So this is the sample of the original data. Now, because 1,200 students are there, and because you have opinions of 1,200 students, you can divide 1,200 students into 3 categories: people who think that they are overweight, people who think they are underweight, and people who think they are just about right. So this division can be made. If you do not make this division, however, then your data is useless, because when you look at it, it does not give you any information. You just know that this is the opinion of one person. This is student 1, and his or her opinion is this. That does not help. But summarizing this is going to help. And these are the types of questions that you can answer if you actually summarize your data. So this is the question. You can answer the question, what percentage of the sampled students fall into each category? So what is the percentage of people who think they are overweight, percentage of people who think they are underweight, percentage of people who think they are about right? So this is one question that you can answer using statistics, using exploratory data analysis. And the next question you can answer is, how are students divided across those 3 body image categories? So that means, are they equally divided? Which means, are the number of students in the overweight, underweight, and about right categories equal? Or if they are not equal, then what kind of percentage pattern do they follow? In which particular category there are more number of students? So these are the types of interesting questions that you can answer using this type of a data set. And to do that, we have to perform exploratory data analysis. So this is what you can do. This is how you can summarize your distribution. And you can see right up there, we have summarized the distribution by finding out what percentage of students found that they were about right, their weight was about right. So the count is given, and then based on the count, you can indeed divide the count by the total number of students, which is 1200, and then multiply that by 100 to get the percentage, which comes up to 71.3%. So this is the percentage of students, which is a really high number, high percentage of students, they feel they are about right. And then the percentage of people who feel they're overweight is coming out to be 19.6%, because the count of such people is 235, which then you can divide 235 by 1200, multiply by 100, you get the percentage. And then the people who think they are underweight is about 110 people who are also who form about 9.2% of the total population, of the total sample. And to calculate that percentage, once again, we will divide 110 by 1200 and then multiply by 100 to get the summary of that distribution. So now the data makes more sense. Instead of just giving you an Excel file with the opinions of 1200 people, I'm giving you this, and this would make more sense to you instead of the Excel file. So this is how you can summarize a given distribution, how you can show the distribution of data. Now, once you have done this analysis, then you would want to show it in the form of a graph, in the form of a picture that is easier for people to understand. Now, what you see here is, as you all must already know, is a pie chart. And in the pie chart, using the same percentages which I calculated earlier, I have just shown different areas. So you can see this big blue area, which shows the maximum percentage of students who are feeling they are about right, and that is 71.3%. And then there's a small yellow area that shows people who think they are underweight, which is 9.2%. So it is smaller than everything else. And finally, the greenish color that you see is people who think that they are overweight, and so that is 19.6% of people. So this is your pie chart, and this is how you can depict this type of data. You could also depict this type of data using a bar chart. So this is a bar chart, and it's very simple. You've just mentioned on the x-axis all the different categories of people, of students, and on the y-axis you've mentioned the percentage. So, and then based on that percentage you have marked these bars, and obviously the blue one is the highest because that's the people who think that their weight is about right. And then the one next to it, which is overweight, which is much smaller than the blue one. And then finally the underweight category, which is even smaller, which is the smallest. So this is another way to represent this type of data. Now, this data was represented using a pie chart and a bar graph, but there are different types of variables. Right now, we were talking about variables about opinions of people about their weight. And this was a categorical variable because there are three categories, right? There is underweight, overweight, and about right. So there are three categories, and that's why it is a categorical variable. But there are also quantitative variables. So two types of variables, categorical, quantitative. What we saw was categorical variable, and we are going to see quantitative variables also, so that you understand how you can show these two. So these are quantitative variables. So what you have here is exam grades of 15 students, and these are the grades they are given. They are not grades, they are just maybe marks or percentages of 15 students. Now you can see you cannot say that this exam grade is categorical because there are so many numbers. These are not categories, these are values for each and every student. But based on those values, I can categorize the score if I want. I can show the count that for this much range of score, what number of students are there. So in this case, I have categorized it. I have written down the range. So you have 40 to 50. Between 40 to 50, the count is 1. So there's only one student having marks between this range. Then 50 to 60, there are 2. 60 to 70, there are 4. 70 to 80, there are 5. And 80 to 90, there are 2. And finally, 90 to 100, there's 1. So this is another way in which you can summarize your data if you are dealing with quantitative variables and not categorical ones. So once you have summarized the data, what you can do now is depict it in the form of a picture, and the best one is the histogram. So remember, the categorical variables can be shown in the form of pie charts and bar charts. Those are more informative. But in the case of quantitative variables, we'll be using histograms. So this is a histogram which shows you the score and the count. So there's an axis with score and there's an axis with count, and we have created a histogram out of this. Now, histograms are very informative, and to understand histograms better, you need to go through these 4 things. Now, I'm not going to cover this in this video. I'll talk about those in the next video, how you can interpret a histogram. So the shape of the histogram tells you something about your data. Center of the histogram gives you an insight into your data. Even the spread, the way it is spread around. And the outliers. Outliers are essentially data items that fall outside of the histogram. It's not very close. Like the histogram we saw earlier was something very close. It was all closed up, close to each other. But if there is some data that falls out of this range, then that would be an outlier. And you'll study how to analyze all these things in a histogram in the next video. So I'll see you there, and thank you for watching.